So, what if you could power our biggest, heaviest industries? I'm talking shipping, aviation, manufacturing, not by digging deeper for fossil fuels, but by turning something like farm waste into a high tech fuel. Well, today we're diving into a blueprint for a truly circular economy that aims to do exactly that.
All right, so here's the game plan. We're going to start with the massive challenge: how to power the stuff that makes the world go round without fossil fuels. Then we'll get into this really ingenious solution: a circular carbon loop. We'll look at the engine that actually drives it, take a quick tour of the places where it's already coming to life, and then finally, we'll wrap our heads around the full regenerative blueprint.
First up, we really need to understand the core problem. We see electric cars on the road, and that's great, but there's a whole other class of industries out there that you just can't plug into a wall.
I mean, these are the heavy hitters of the global economy. We're talking about those massive container ships crossing oceans and jets flying halfway around the world. They can't run on batteries. They need an incredibly dense portable fuel. So the big question is, how do we make that kind of fuel without burning fossils?
And the answer? Well, it lies in this really brilliant concept called power to X. Basically, it's a way to take clean, renewable electricity, that's the power, from something like solar or wind and convert it into a stable, transportable fuel, that's the X. It's almost like bottling pure sunshine into a liquid you can pour into a tank. So these new molecules are pretty much the lifeblood of this new regenerative economy. You've got green ammonia, which is perfect for shipping. You've got e-kerosene, a sustainable fuel for aviation, and e-methanol for other big industries. Every single one of them is designed to be a direct, clean replacement for the dirty fuels we're using now. But, just creating green fuels is only half the story. The real genius here, the part that makes this so different, is where the carbon for those fuels actually comes from. See, this isn't just about making clean energy, it's about building a system that's completely circular.
And this is where we see this just fundamental shift in thinking. For 100 years, we've treated carbon dioxide like a waste product, something to get rid of. This new model completely flips that idea on its head. It treats captured carbon as a valuable raw material, a key ingredient for the next generation of fuels. It's an asset, not a liability.
Okay, so this soil-to-sea loop, this is the heart of the whole system. It all starts with agricultural waste. So instead of just letting it rot and release carbon, you convert it into the stable, carbon-rich material called biochar. Now, the CO2 that's released during that process gets captured and combined with green hydrogen to make our fuel. And the biochar itself, it goes right back into the soil, making it healthier and locking away carbon for a really long time. It's a perfect, elegant circle. So the concept is powerful, no doubt about it. But a big idea like this needs a really robust structure to actually become a reality. How do you go about building this global engine?
The first crucial piece is how you organize everyone. To pull off something this huge, you need what's called a consortium. And this isn't just some casual partnership. It's a formal alliance specifically designed to handle massive, complex projects by bringing all the key players, industry, finance, government, to the same table.
Think of it like this. A consortium is built for top-down speed and complexity. It unites the giants. A cooperative, on the other hand, is built for bottom-up, democratic organization, which is absolutely perfect for, say, getting biomass from hundreds of local farmers. You need both of these structures, and they each have to play to their strengths. So the key takeaway here is that it's not an either-or kind of deal. You need both. The consortium is the top-down industrial engine that gets the massive infrastructure built, and the cooperative is the bottom-up supply chain engine that gathers all the raw materials.
And of course, the other key piece of the architecture is the funding. How do you pay for all this? Well, a project this ambitious can't rely on just one source. It uses a clever strategy called blended finance, which basically pools capital from a whole mix of players. We're talking sovereign wealth funds, development banks, private investors, and even revenue from carbon credits, all of them working together to build this thing out.
Okay, so now that we have the blueprint, let's actually see how this system adapts to different places around the world. It creates these things called soil-to-sea corridors. Let's take a look. Now, the beauty of this model is just how adaptable it is. It's not one size fits all. You could see right here how three completely different regions, Switzerland, the UAE, and the US Midwest, can each play a unique but totally complementary role, all based on their own distinct strengths. So you've got Switzerland. With its world-class finance and engineering sectors, it plays the role of the system's brain. It focuses on what it does best: managing the intellectual property,
orchestrating the complex financing, and providing that trusted, global certification for the fuels. Then you look at the UAE. With its unbelievable solar resources and deep capital reserves, it becomes the reactor core. And just think about that for a second. This is a traditional oil superpower, making a huge strategic pivot to become a dominant force in the green energy of the future. That's a massive shift. And in the United States, you get this enormous commercial corridor that connects the agricultural heartland, literally the largest on Earth, with the industrial power of the Gulf Coast. This creates a seamless, huge-scale pathway from regenerating the soil all the way to global export. Okay, so let's zoom all the way out. What's the big takeaway here? Why does all of this really matter? Well, at the end of the day, this isn't just about making cleaner fuel. It's a blueprint for an economy that actually heals the planet while it powers it. It creates a direct economic link between the health of our local farmlands and the decarbonization of our global skies and seas. I mean, it is a truly bold vision, turning our biggest waste problems, all that excess CO2 and agricultural residue, into the very foundation of a regenerative global economy. So I guess the question isn't really if we can do it anymore, but how fast can we build it?